All right. Now let's get this slide because I'm going to give you some equations. In case y'all haven't seen yet, I make my sevens with the cross through them. What else? My handwriting's really bad. That's a 3 up there. Okay? 3 equations. These top 2 equations are the same equation. These 2 are the same. They're just rearranged. And I know a lot of students that are in this class aren't comfortable rearranging it. So you just got to know both of them then. How's that? Does everybody have them all written down? So if I give you temperature in Celsius and you want to go to Fahrenheit, you put the Celsius temperature right here, multiply by 1.8, then add 32. If I give it to you in Fahrenheit, and you want to go to Celsius, you put it right here, subtract 32, divide by 1.8. If I give it to you in Celsius and you want to go to Kelvin, you add 273 and I'll give you Kelvin. This one's easy, huh? What if I give it to you in Fahrenheit and I ask you for Kelvin?
You have to change it to Celsius first.
You got to go to Celsius first and then you add 273. Okay? Must know. You prefer just regular equations because there's you know, you don't have to like figure anything out here, do you really?
No.
As long as you got the equation, you can solve it, right? Okay. Y'all got the equations in. Here we go. Yeah, that's what we're talking about. Okay. So a person with hypothermia has a body temperature of 34.8 degrees Celsius. What's that temperature in Fahrenheit? Work that out real quick. So what do? Multiply 1.8 times 34.8 and then add 32 to it. So the answer is?
94.6.
This person's sick.
Yeah. Well, yeah.
They got problems.
That's not wrong.
They're extremely cold, right? They're in danger. Okay, when your body gets too cold, all your organs and stuff start shutting down, right? Yep. So it's not good. Must warm them up. All right, well, can you answer this one then? What do we got?
D.
C, D. Who says, all right, let's vote. A, B, C, and D. Ray, set, vote. What you got, Shoes? Huh?
I have to do it still because I did it on my phone, but now I'm not sure.
All right, well, let's do it real quick. So what's the equation? Temperature Celsius equals temperature Fahrenheit minus 32 divided by 1.8, right?
Mm-hmm.
So So 15 minus 30, negative 15 minus 30, so negative 47 divided by 1.8 should be negative 26. Okay? All right, well, here's one for you. What's wrong, Maggie?
We can get two different answers. Do we need to worry about significant errors?
Yes. 3 for this particular problem. The numbers within the equation are exact, so you would have report the ones that you start with. No! I'm trying to make a point. Who got negative 40?
Oh,
The answer is negative 40.
okay.
Oh, I didn't do the negative.
Can you run through that one?
Can I run through that
I
one?
mean, on the board.
Yeah. So, what's the equation? Temperature Fahrenheit equals what? 1.8 times temperature Celsius plus 32, right?
Yeah.
So negative 40 times 1.8.
It's negative 72.
Did I do that right? I did it wrong. No, I didn't.
Yeah, that's right. Negative 40 times 1.8 plus 32.
Plus 32. So it's negative 72 plus 32 gives you negative 40, right? All right. Now a lot of you are going, well, that can't be right. There's no way the two can be the same, right? I'm going to show you why that is. All right, watch. When water boils, what's the temperature in Fahrenheit? 212, and Celsius, it's 100, right? So what's that difference? 112. Well, the melting point is 32 and 0. So this difference is, what does it look like's happening? They're getting closer together, aren't they? And eventually they're going, we always think about Fahrenheit as being greater than Celsius, but once you get below negative 40, then Celsius, the number will be greater than Fahrenheit. It's like,
So melting point the same thing as freezing?
melting point, freezing point, just depends upon which direction you're going. It's like, here's a mathematical explanation for you. It's two lines like that, right? Negative 40 is the point at which they cross. They're not railroad tracks, they're not parallel. They're two lines that are going to cross. Okay? And they cross at negative 40 degrees Fahrenheit or Celsius. Okay. I was just trying to make a point to convince you to trust yourself a little bit. You were unsure, weren't you? Because you're like, oh, that don't seem right. Because normally Celsius is a lot lower than Fahrenheit to us, but it's not in this case, okay? All right, we're not going to do that one. Can you do this one? This should take you like 2 seconds. What's body temperature in Kelvin?
10.
That's all you gotta do, right? All you gotta do is what? Temperature Kelvin equals temperature Celsius plus 273. Okay? Did I do that right? 310 Kelvin? That's an easy problem we're ever gonna have right there. That's way easier in centimeters to inches, isn't it?
Mm-hmm.
Are we gonna have to memorize those?
All these
conversions,
formulas and
like,
All right, I'm gonna pay for that. Yeah.
we have to memorize them?
Pay.
Um,
Which
Well,
one?
she's asking,
like,
are we gonna be
like
able,
the inches to,
I told you need to know centimeters and inches.
well, we're not gonna be able to use a card of any kind.
No.
okay.
I've told you everything that I expect you to know.
Yeah.
If I said you must know 2.54 centimeters equals 1 inch, you don't need to know it. And I told you you need to know kilo, centi, deci, milli, micro.
And now these.
173.
So not hadn't been really that much.
We're in the third week or fourth chapter.
Fourth week. All right. Well, what did we say temperature was? Temperature is an indicator of energy, isn't it? Okay. Let's talk about energy a little bit. Energy makes objects move. It makes things stop. It is defined as the ability to do work. Are you doing any work right now?
Yes.
Moving your pencil? Who in here is breathing? Does it require work to breathe?
Yes.
The diaphragm has to move up and down, doesn't it? Are you blinking your eyelids? Moving your eyes around? Use muscles to do that, don't you? Where do you get the energy from to do that? Think, man. Where do you get the energy from to do all that?
On my muscles.
How do you get the energy to do the work that you do?
Food and water.
Food. Water doesn't have any energy in it. Or it does, but we don't harvest energy from water. How's that? Calories. You gotta eat some donuts, don't you? Or some chocolate cake. Huh? I had chili for lunch. So I'm working on my chili right now, right? My chili is my energy for the afternoon. This morning I had a chicken biscuit from Bojangles.
Was it good?
It's always good. So that provided me energy for the morning, right? And what do we call it? What are the units of that energy that we normally talk about? Calories, okay? Now we're going to talk about calories, but our calories can be a little bit different. We'll come back to that calories in a few minutes, okay? Energy can be divided into two kinds. Kinetic energy, which is energy of motion. When your diaphragm moves up and down when I walk back and forth in this room. It takes work to move this big old body around this room, doesn't it? I hope I ate enough calories to do that. Clearly I did, because if I didn't, I got extra storage here, right? I got plenty of extra energy to move me around this room, okay? Kinetic energy is the energy of motion, and we'll talk about motion. Water flowing, doing work, your car going is doing kinetic energy, right? When your car moves, that's kinetic energy. Potential energy is energy that's stored. So when I ate my chili at lunch, there was energy stored in that chili, right? Had some ground meat in it, had some beans, had some tomatoes, had a little bit of jalapeno, right? Some onions. All those things contain energy. And I'm now using that energy and I'm converting it into kinetic energy by walking and talking and moving my arms and flailing around, right? Does your car do that? It takes the potential energy of the gasoline and converts it into motion, doesn't it? Same thing. You gotta fuel your tank every day, don't you? You gotta eat, don't you? Because when you run out of potential energy that's stored right here, just like when your car runs out of energy, what happens? Stop. Okay? So, are these things potential or kinetic energy? Rollerblade. That's movement, right? That's kinetic. Peanut butter and jelly sandwich. Is that a lot or a little bit of potential energy? A lot of potential energy in peanut butter and jelly sandwich. Mowing the lawn. No matter if you're on a riding lawnmower or you're pushing, you're still moving, right?
What if you're just considering?
If you're just considering it, that's fine. That don't count. Gasoline in your gas tank in your car is potential, the potential to do work, right? It can do work eventually.